empezamos. Una vez más estoy aquí como dos personas al mismo tiempo, como reemplazante del director del programa, porque soy miembro del comité del programa de Magister en Física y claro como profesor guía de Tesis del Diego también. Entonces ahora tengo el gorro del director del programa y da bienvenido a todos que vinieron. Y hoy tenemos la defensa de tesis de Magister de Diego y tienes como 35 minutos, 40 más o menos para tu charla. Después tenemos las preguntas del comité, que es profesor Dominik Schleicher, profesor Amelia Stutz y claro, con el otro corro después conmigo. Y también, ojalá, algunas preguntas del público general también. La charla está en inglés. Without further ado, we are here now steering up an embedded star cluster with a moving gas filament, the defense of Diego. Please.
Good afternoon everyone, and thank you for being here. Today I'm going to show you the results of this investigation that I've been doing the last 2 and almost 3 years. So I will start immediately talking about embedded clusters. Embedded clusters are the young step of a star cluster. They are called embedded because these stars are still inside the gas cloud that is forming them. Most of the mass of the system is still in the form of the molecular gas, and only a few % can be found as stars. So the dynamics of the system, the gravity of that the stars are feeling, are dominated by the gas and not by the stars. Since these kind of clusters are still inside the gas and molecular cloud, they are very hard to see on the optical, and so they have to be observed using infrared telescopes. And as the stars evolve and they enter the main stage of their life, main sequence, they will start to remove this gas, and so the degree of embeddedness will also indicate the age of the system. Now, these young star clusters are formed inside molecular clouds. These are clouds made of cold gas, so we can find different kinds of molecules here. Since these embedded clusters are formed in molecular clouds, most of the stars that we can see on the sky were formed inside this kind of objects. And they have different shapes, and between them the gas can form large filaments for up to hundreds of parsecs on length. And inside these filaments the gas starts to collapse and form new stars and clusters. One of the most famous examples for molecular cloud can be found in Orion. Here is Orion A, a molecular cloud. And in the northern part of this cloud we can find one of the most famous nebula that we can see even with the naked eye on the sky, the Orion Nebula. The nebula is bright because the young stars that are inside the nebula are emitting radiation that excites the gas and emit in the optical. And these young stars belong to the Orion Nebula cluster, named since because it's a cluster in the Orion Nebula. So this cluster has a mass of around 1,000 solar masses and is located at a distance of more or less 400 parsecs. So it's one of the most important sites of high star formation that is available to us. Here we can observe the young star and the different parts of their formation. But as we can see in the image, this cluster is not spherically distributed. It's actually elongated around one axis. This is due because this cluster is still embedded inside a gas filament called the integral tape filament. The name is because, well, as you can see here, the cloud has the shape of an integral sign, and in the middle is located the Orion Nebula cluster. This filament, the integral shaped filament, has an extension of around between 7 and 8 parsecs, but the Orion A as a whole has an extension of almost 80 parsecs. Observations of the young protostars show that these are located right on top of the ridge line of the filament, but the older stars have a more broader dispersion. The right image on the screen. Also, the younger stars have a lower velocity dispersion, and the older stars have a larger velocity dispersion. That means that as the stars evolve and become older, something is giving them that extra energy to have larger velocities and reach a larger distance from the filament. Stutz and Gold in 2016 proposed that this is due to the slingshot mechanism.